Okay, let's differentiate or take the derivative of f of x. Now we could spend a long time multiplying this all the way out, so we just have to use the power rule. Instead, I'm going to treat this as two things multiplied together, and I'm going to use the product rule. So the first one I'm calling g, the second big set of parentheses, I'm going to call that h. So the product rule says we take the derivative of the first, multiply it by the second, plus keep the first one the same, and multiply by the derivative of the second set of parentheses. So jumping right in here using the power rule, derivative of g, the first set of parentheses, 5 comes down, multiply it by 4, makes 20, reduce it by 1, 5 minus 1 makes 4, plus derivative of x cubed, again power rule again, exponent comes down, reduce it by 1, minus power rule for that third term, 1.5 times 2 makes 3, x to the first power as we reduce down that exponent by 1. All right, the plus 11 here at the end, that's a constant, so its derivative is going to be 0. So I'm not going to put a plus 0 at the end, although we could. To that, we're supposed to multiply h, so we're going to simply copy down all of h, that second set of parentheses. Trying to do this quickly, because it really is just copying it all down. To that we add g, so the first set of parentheses, again, just copy the whole thing down. And we're supposed to multiply that by the derivative of h. So h is my second set of parentheses. So again, power rule repeatedly throughout this. So the derivative of x to the 7th is going to be 7x to the 6th. Bring the exponent down, reduce by 1. Next, we have minus 7.25 times 5 is 36.25. X to the 4th power is we reduce that exponent by 1, plus the derivative of that linear term is going to be 120. And then a plus 0 at the end if we'd like for that derivative of 3, but we don't really need to. All right, so it looks big and scary, but that is our derivative. I would leave it just like that. I wouldn't bother multiplying out or worrying about combining like terms. That's our derivative. Hope this helps. Good luck.